Hi, in this video we'll quickly cover logical operations. Let's say I have a vector x with the values -1, 1, and 0. I can test which element equals exactly 1 by using two equal signs, and I'll get a logical vector with true at the element and false everywhere else. I can also test less than, greater than, or greater or equal than 1 by using those symbols. Notice that it is not okay to use equal then greater because the order does matter. Sometimes it's useful that I want to know which elements are less than 0 or greater than 0, meaning I want at least one of the conditions to be satisfied. In this case, I can use the OR operation. This vertical bar is usually located right above your return key, and then OR greater than 0. Again, I want to see which elements are x are less than 0 or greater than 0. At least one of the conditions to be satisfied. Then I'll get a true there. Well, sometimes I also want to know which elements are less than 0 and less than 1, meaning I want both conditions to be satisfied. In this case, you can use the ampersand that stands for the AND operation. This will return true only if both conditions are satisfied and false everywhere else. Let's try to visualize this. Again, x is the vector -1, 1, and 0. Let's say if I ask the question which elements in x are less than 0 or greater than 0. Then I'm asking which elements are at least satisfying one condition. Again, the first vector returns true only for the first element, and the second vector returns only true for the second element. Then the final output, since the first two elements satisfy at least one of the conditions, they'll both be true. The third element will be false because it satisfies neither condition. Now for the AND operation. If I ask which elements are less than 0 and less than 1, I'm asking for both conditions to be satisfied in this case. Again, the first vector will be true only for the first element, but in this case, the second vector will be true for the first and third element and false for the second. In this case, only the first element is true for both conditions, and that's why the final output is only true for the first element and false everywhere else. Lastly, I can test equality for things other than numeric vectors. Let's say I have a character vector with uppercase and lowercase mel. I can see which elements equal to the lowercase mel, so in this case, case does matter. Or I can test equality for logical vectors, such as which elements equal to false. Sometimes it's useful to know which elements in x does not satisfy a certain condition. In this case, we can use the exclamation point to negate the logical vector. That turns all the trues into falses and all the falses into true. This also works for other operations as well. Now we know how to create logical values. Well, how do we work with them? Imagine we have the vector like this, and I can get the values in x that are less or equal to 1 by doing that. And I can count how many of them are less or equal to 1 using the sum function, or getting the proportion of them less or equal to 1 using the mean function. The reason this works is because numeric operations with logical values, the trues are in general treated as 1s, and the falses are treated as if they are 0.